You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your educational journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. Right-sizing is the discipline of shaping increments into the smallest coherent units that still deliver meaningful outcomes. The orientation is that smaller does not mean trivial. It means designing slices that maximize learning and benefit while controlling risk, cost, and coordination overhead. Teams that fail to right-size fall into one of two traps: overly large batches that delay validation until late, or overly fragmented tasks that fail to create observable value. Right-sizing avoids both by focusing on thin slices of end-to-end behavior that are testable within a time box. These increments accelerate feedback and reduce waste because missteps are discovered quickly and reversals are safe. By embedding right-sizing into planning and refinement, organizations ensure that delivery remains predictable, quality remains high, and benefits remain observable. This discipline transforms scope from an abstract list of tasks into a dynamic set of value experiments aligned to strategy. The small batch rationale explains why right-sized increments outperform larger, bundled deliveries. Smaller slices reach stakeholders faster, producing earlier feedback that guides decisions before costs accumulate. They also reduce variability, as the uncertainty in one thin slice is easier to manage than in a massive release. Reversals are safer too. If a small increment produces negative signals, rollback is less costly than undoing an entire large batch. For example, a team might release just the search portion of a new customer portal rather than waiting to ship search, checkout, and account management together. If search fails to meet expectations, course corrections can occur before further investment. This approach improves both flow and decision quality, turning delivery into a steady cadence of validated steps rather than a risky leap into the unknown. Small batches minimize exposure while maximizing learning. Vertical slices are the preferred format for right-sized increments because they represent complete end-to-end behavior. Unlike horizontal slices that address only a single layer, such as database schema or user interface, vertical slices combine interface, logic, and data into a usable or testable outcome. This approach avoids postponing validation until all layers are eventually stitched together. For instance, instead of building a database table now and a user interface later, a vertical slice delivers a working add-to-cart feature that spans storage, logic, and presentation. Stakeholders can interact with it immediately, and systems can verify integration. Vertical slices are smaller but coherent, producing learning and outcomes in one pass. By prioritizing vertical over horizontal decomposition, teams maintain alignment with real value rather than technical artifacts. This preference ensures that right-sized increments are observable and meaningful, rather than partial and deferred. The coherence test helps teams validate whether an increment is truly right-sized. A coherent increment has a clear goal, defined acceptance, and an observable outcome for a user or system. Without coherence, slices risk becoming fragments of effort that cannot be judged for value. For example, a coherent slice might be enable password reset via email link, with acceptance criteria showing successful resets logged and verified. An incoherent slice would be build email template without integration, which delivers no observable outcome. The coherence test protects against slices that are technically smaller but strategically meaningless. It ensures that increments are not just reduced in size but crafted to deliver testable benefits. Coherence transforms right-sizing from mechanical decomposition into outcome-oriented design, where every increment can stand on its own as a hypothesis tested in reality. Scope negotiation reinforces right-sizing by structuring flexibility through must, should, could categories. The must items preserve the core outcome, ensuring that the increment delivers its primary value even under constraint. The should items add desirable enhancements if capacity allows, while the could items are optional extras. For example, a payment feature might define must process card transactions successfully, should support mobile wallets, and could add loyalty points integration. This approach allows scope to flex without losing focus on the essential outcome. Negotiation makes trade-offs transparent, protecting teams from overcommitment and stakeholders from disappointment. It also creates a shared framework for adjusting scope responsibly when capacity tightens or deadlines approach. Scope negotiation ensures that right sizing is not only about decomposition but also about disciplined prioritization. Cost of delay framing strengthens scope decisions by quantifying urgency. Some value decays quickly if not delivered in time, while other benefits are more durable. Right sizing prioritizes slices where delay carries the highest cost. For example, a feature supporting a seasonal promotion may lose nearly all value if late, while an internal tool improvement might hold its benefit longer. Smaller, earlier slices allow time-sensitive increments to land before value evaporates. Cost of delay transforms scope from abstract prioritization into economic decision-making. It guides teams to deliver smaller, outcome-true increments that capture fleeting opportunities before they disappear. By making urgency visible, cost of delay ensures that right sizing maximizes impact relative to time. Decomposition patterns provide structured options for right sizing without losing intent. The SPIDR model spikes, paths, interfaces, data, and rules helps teams think systematically about how to split increments. A spike explores an unknown, a path represents a user journey, interfaces separate channels, data slices test conditions, and rules isolate logic variations. For example, when tackling a claim system, a team might start with a spike to test vendor integration, then deliver the happy path for standard claims, followed by one interface channel, typical data ranges, and finally, exception rules. These patterns provide reliable handles for breaking down work while preserving outcome orientation. Decomposition is not arbitrary but guided by proven techniques, ensuring that increments remain thin, testable, and coherent. Non-functional risk shaping reminds teams that right sizing is not only about functionality. Performance, security, and operability concerns must be pulled forward when exposure is highest. For example, if a feature risks slowing system response, a slice may include a performance benchmark test even before full functionality is complete. Similarly, if security compliance is critical, encryption or access control tests should be part of the earliest increments. By shaping slices to include non-functional risks where they matter most, teams protect themselves from late-stage surprises. This practice keeps increments safe to release, preventing rework and reputational damage. Right sizing must therefore balance visible features with invisible qualities, ensuring that increments are small but still defensible. Dependency-aware shaping ensures that increments remain deliverable even when external systems or partners are not ready. Instead of stalling, teams use stubs, adapters, or contract tests to simulate integrations. For example, a team waiting for a payment gateway might build a stub to mimic responses, allowing their checkout process to progress. Later, the stub is replaced with the live integration. This strategy maintains flow while reducing risk from dependencies. It ensures that right-sized increments remain productive, delivering learning and outcomes without being blocked by external timelines. Dependency-aware shaping keeps progress continuous, demonstrating that agility means adapting scope to circumstances rather than waiting passively. Capacity realism and work-in-process limits keep right-sizing grounded in what teams can actually handle. If increments are right-sized but too many are started at once, quality and predictability still collapse. By aligning scope to empirical throughput and limiting concurrent work, teams preserve flow. For example, if a team historically completes 5 increments per iteration, they should not commit to 10, even if each is small. Realism respects data over ambition, ensuring that commitments are sustainable. Work-in-process limits prevent overload, making sure that increments finish and deliver outcomes rather than linger half-done. Right sizing must therefore be paired with disciplined capacity management, keeping flow steady and predictable. Hypothesis-driven increments make learning explicit, turning right-sizing into a scientific process. Each slice is framed as a hypothesis, with signals that will confirm or reject it. For example, if we introduce a one-click checkout, we expect to see abandonment rates drop by 10%. The increment is then tested against this signal. If the outcome is positive, the next slice builds on it. If negative, the plan pivots. By making increments hypothesis-driven, right-sizing becomes a cycle of evidence-based decisions rather than speculative delivery. This practice aligns work tightly with learning, ensuring that scope is shaped around what can be validated. Featured toggles and staged rollouts give teams the ability to decouple deployment from release. Right-sized increments can be deployed into production but hidden behind toggles, allowing targeted exposure to test groups before full rollout. Staged rollouts, such as canary releases or regional launches, limit blast radius if signals go negative. For example, a new recommendation engine might first be enabled for 5% of users, then expanded gradually. These techniques make right-sizing safer by allowing small increments to generate high-quality signals without risking system-wide disruption. They reinforce agility by making release reversible and exposure controlled. Stakeholder trade-off forums support right-sizing by making scope choices transparent. Forums present option sets, their consequences, and the evidence behind them. For instance, stakeholders may be shown that including mobile support adds 2 weeks but improves adoption by a projected 10%. With options laid out, trade-offs are decided collaboratively rather than imposed silently. This transparency prevents scope creep and maintains trust. It also ensures that decisions reflect shared priorities rather than local optimization. Trade-off forums make right-sizing a participatory process, aligning all voices around evidence-based choices. Readiness criteria confirm that slices are prepared before being pulled into execution. Each increment should have context, acceptance, risks, and telemetry notes defined. Without readiness, increments may enter work prematurely, causing thrash and rework. For example, a slice without telemetry design cannot produce the signals needed for validation, leaving stakeholders blind. Readiness checks prevent this by ensuring that increments are not only small but also actionable. They preserve predictability and reduce wasted effort. By embedding readiness into right-sizing, organizations maintain discipline and ensure that increments deliver learning as designed. Anti-patterns remind teams what to avoid when shaping scope. All-or-nothing batches defeat the purpose of right-sizing by bundling too much together. Just add this to creep inflates increments until they exceed capacity. Quality shortcuts may make slices appear smaller but create rework later, negating any efficiency gained. These traps erode trust and destroy predictability. By calling out these anti-patterns, organizations reinforce discipline. Right-sizing is not about cutting corners but about shaping increments to maximize value and minimize risk. Avoiding these pitfalls ensures that scope remains lean, coherent, and effective. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Increment goal alignment ensures that scope serves one clear objective per delivery window. When multiple goals compete, increments become diluted and acceptance conversations lose focus. By tying scope directly to a single increment goal, teams can prioritize cleanly, measure progress clearly, and avoid confusion over what matters most. For example, if the goal is to reduce onboarding abandonment, scope should include only the stories and slices that advance that outcome. Other worthwhile ideas wait for future increments. This discipline simplifies acceptance, as success is judged against one target rather than many. Goal alignment also prevents overloading, since each increment is measured against one hypothesis at a time. Right-sizing becomes sharper when scope is anchored to one clear purpose. Cycle time guardrails provide early warning when increments are drifting beyond intended size. By monitoring percentiles of cycle time, teams can spot items that age too long in progress, signaling scope bloat. For example, if 90% of increments finish within 5 days but one item lingers for 15, it may need further splitting. Guardrails transform cycle time from a retrospective measure into a proactive diagnostic tool. They encourage decomposition before delays become incidents. By treating aging items as signs of poor right-sizing, teams maintain flow and predictability. Guardrails reinforce the principle that increments must remain small enough to finish quickly and deliver value promptly. Contingency buffers build resilience into scope planning. No matter how well increments are shaped, integration challenges, test stabilization, or unforeseen risks may arise. Reserving a small portion of capacity for these realities prevents optimistic planning from collapsing under pressure. For example, a team may hold back 10% of their iteration for unexpected rework. If the buffer is not needed, it can be used for backlog improvements or technical debt. Buffers protect commitments, ensuring that the increment goal is met even when surprises occur. They acknowledge uncertainty without surrendering predictability. Right-sizing includes recognizing that some capacity must remain flexible for the unknown. Canary and ring release patterns make right-sized increments safer by limiting their initial exposure. A canary release deploys the increment to a small set of users first, monitoring behavior closely before broader rollout. Ring releases expand this exposure in stages, such as internal staff, a regional subset, and then all customers. These patterns allow teams to gather high-quality signals while protecting against large-scale disruption if issues arise. For example, a new recommendation engine might be released to 1% of traffic first. If results are positive, rings expand until full adoption. These strategies keep increments reversible and learning-focused, ensuring that scope can be tested without risking the entire system. Contract-first integration protects right-sized increments that rely on external systems or partners. By defining interface expectations, compatibility guarantees, and testable contracts up front, teams ensure that slices evolve safely across boundaries. For example, two teams building complementary services can agree on a contract describing inputs, outputs, and error codes. Each team develops against the contract independently, verifying compliance through automated tests. This approach prevents delays caused by mismatched assumptions discovered too late. Contract-first practices also make integration predictable, reducing the risk of rework. By embedding contracts into right-sizing, teams ensure that increments remain coherent even when multiple groups are involved. Quality gates and pipelines enforce the definition of done automatically. Tests, security scans, and operability checks must pass before an increment can be considered complete. This automation prevents last-minute heroics, where quality is verified manually under time pressure. For example, a gate may block deployment if coverage drops below a threshold, or if critical vulnerabilities are detected. Quality gates ensure that right-sized increments remain trustworthy and safe to release. They also standardize expectations, making success criteria consistent across cycles. By embedding quality into pipelines, teams reinforce the principle that small increments must still meet full standards, not just partial ones. Observability per slice makes increments measurable and reversible. Each slice specifies logs, events, and dashboards that confirm behavior and signal whether rollback is necessary. For example, a new login feature might capture error rates, authentication latency, and user drop-off metrics. If signals exceed thresholds, rollback is immediate. Observability ensures that right-sizing produces not only functionality but also insight. Without it, small increments may still fail silently, undermining trust. By embedding observability, teams connect scope directly to evidence, ensuring that increments deliver learning as well as outcomes. It makes each slice a self-contained experiment with built-in accountability. Documentation minimalism prevents scope from bloating under the weight of unnecessary records. Right-sized increments should capture only durable, high-signal context, such as decision rationale, contracts, and runbooks, while avoiding exhaustive documentation that adds little value. For example, instead of producing detailed meeting minutes for every refinement, teams may record only the decision log and acceptance criteria. This minimalism preserves auditability and traceability without slowing flow. It also ensures that documentation remains relevant and usable rather than sprawling into noise. By keeping records lean, right-sizing maintains agility while still supporting transparency. Documentation becomes a guardrail rather than a burden. Recomposition and cleanup are essential after learning stabilizes. Temporary toggles, stubs, and scaffolding used to right-size increments must eventually be retired. If left in place, they clutter the codebase and create hidden complexity. For example, once a feature flag has been fully rolled out, it should be removed, simplifying the system. Similarly, stubs should be replaced with live integrations once external systems are ready. Recomposition restores clarity and health to the system, preventing the accumulation of technical debt. It acknowledges that while scaffolding is necessary for experimentation, permanence requires consolidation. Cleanup ensures that right-sizing supports long-term quality rather than degrading it. Portfolio balance prevents right-sizing from devolving into overfragmentation. While thin increments accelerate feedback, too many scattered slices can overwhelm coordination. Portfolio practices bundle related, verified slices into coherent releases when readiness aligns. For example, several increments improving checkout flow might be bundled into a release that delivers a full, validated experience. This balance maintains agility while ensuring that outcomes are meaningful at scale. Portfolio balance prevents stakeholders from drowning in micro-slices while preserving the benefits of fast learning. It ensures that right-sizing remains practical for both teams and organizations. Vendor coordination extends right-sizing across external boundaries. External deliverables and service-level agreements must align with the cadence of small increments, not just with big bang releases. For instance, if a cloud provider supplies an API needed for testing, their availability must be coordinated with the team's increment schedule. Without this alignment, external delays stall progress. Coordinating with vendors ensures that dependencies remain compatible with right-sized delivery. It makes agility systemic, not just internal. This practice reinforces that value flow requires collaboration beyond organizational walls. Remote-friendly refinement ensures that scope shaping remains inclusive in distributed environments. Pre-reads allow participants to review options asynchronously, while concise sessions focus only on decision-making. Digital tools make slicing collaborative without meeting sprawl. For example, a team may circulate decomposition proposals in advance, collect feedback in shared documents, and then finalize scope in a short video call. This rhythm prevents fatigue while still producing quality increments. Remote-friendly refinement demonstrates that right-sizing is compatible with modern work patterns, ensuring inclusivity and efficiency across geographies and time zones. Outcome reviews close the loop by comparing observed signals to intended benefits. If results are weaker than expected, the response is not silent carryover, but further slicing or scope rethinking. For example, if a new recommendation feature increases engagement by only 2% instead of the targeted 10%, the team must decide whether to refine, pivot, or retire. Outcome reviews prevent complacency and enforce evidence-based alignment. They ensure that increments are judged by impact, not just delivery. This discipline turns right-sizing into a feedback-driven cycle where scope continuously adapts to maximize value. Success evidence confirms whether right-sizing improved flow and outcomes. Signs include shorter feedback loops, steadier delivery tempo, and fewer escape defects. For example, stakeholders may note that decisions are made faster because increments produce data sooner, or that rework decreases because problems are caught early. Success evidence validates the investment in decomposition and discipline. It proves that right-sizing is not just a theoretical ideal, but a practical driver of higher value per time box. By tracking these signals, organizations reinforce the habit of shaping increments thoughtfully, ensuring that the practice endures and evolves. Right-sizing synthesis highlights how shaping scope into thin, coherent increments maximizes validated value under real constraints. Goal alignment keeps focus clear, Guardrails and buffers protect predictability, and staged releases reduce risk. Contracts, quality gates, and observability ensure that slices are safe, testable, and reversible. Minimalism and cleanup preserve agility, while portfolio balance and vendor coordination scale the practice responsibly. Remote-friendly refinement and outcome reviews embed inclusivity and evidence, while success signals confirm the benefits. Together, these practices demonstrate that optimizing value means delivering smaller, smarter, safer increments that create learning and impact consistently. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.